Hello everyone. In this video I'm going to speak about the nuclear atom. Let's get started. The nuclear atom lesson could be very easy for some of you, but still one of the most important lessons that we should not underestimate. We can see here, we have here an atom. We have protons and neutrons, positive protons and neutral neutrons, and they are found in the center of the atom, making up the nucleus. Then we have electrons. Electrons are surrounding the atom, surrounding the nucleus, and they are moving in what's called energy levels. We can see here, this is Na. Na is representing sodium. Each element or each atom is coming with two numbers. Like here in sodium, we have 11 and 22.99. We have the atomic number, which is 11, Z. It is representing the number of protons in an atom. And of course, when we have an atom, it means that it is neutral. Why it's neutral? Because the number of electrons, number of negative electrons is equal to the number of positive protons. Then we have the big number, which is representing the atomic mass, number of protons, and number of neutrons in an atom. And of course, to calculate the number of neutrons, we can do that through mass number minus atomic number. Then we'll find the number of neutrons. Okay. Next, we need to know about the ions. We have two ions, cation and anion. What is the cation? It is the positive ion. So cation is always positive ion, while the anion is representing the negative ion. Let's check here. We have an example. We have magnesium. How we may check if magnesium will make positive or negative? We have to check the atomic number. What's the atomic number for Mg? It's 12. So we need to write its electronic configuration in the main energy levels. So it's 2A2. The concept about the formation of ions is for the atom to be having a last full shell. Last full shell. So how magnesium could have last full shell? By losing 2 or gaining 6. The last full shell should be 8. How it could magnesium have a full last shell? By losing 2 or gaining 6. Of course, it's easier to lose 2 electrons, so it will become Mg2 positive. So we have here, as you can see, we have here less electrons than protons, less negative than positive. So it is 2 positive ion. We have here another example. We have here Cl. It's atomic number 17. So we will write the electronic configuration 287. 287. So it's easier to gain an electron than losing 7 for the purpose of having full last shell. So it will be Cl negative. As we can see here, it has more negative than positive. So for that reason, it is negatively charged ion. Okay, the next point is about isotopes. Here we have isotopes for carbon. The isotopes could be described as atoms of the same element. They still same element, carbon, carbon, carbon. But they have a different mass number because they are same element, so they must have the same atomic number. So they have the same number of protons, but different number of neutrons. Because they are, the isotopes are for the same element, so they have the same chemical properties. So they react in the same way, but different physical properties, of course, because they have different masses. So they have different melting and boiling points. The relative atomic mass, AR, is called relative, and we can see that it is coming in, we have decimal because it is a relative atomic mass, and it's depending on the natural abundance of each isotope in the sample. So, to calculate the relative atomic mass, we care about two main things. We care about the mass number and its natural abundance in the sample. The mass number and its natural abundance in the sample. Okay, so if you would like to calculate it, we use very simple formula. AR is equal to percentage of isotope 1. It means the natural abundance for the first isotope by the mass of isotope 1. So we have here, this is the percentage or the natural abundance of the isotope 1 multiplied by the mass, which is 35, plus percentage, which is the natural abundance of the second isotope multiplied by the mass number here all over 100. So we will have 75.77 by 35 for the first isotope, 24.23 by 37 for the second isotope all over 100. Then we will have the relative atomic mass for Cl, and this is what you will see in the periodic table. It is a relative atomic mass because it's depending on the different isotopes and their natural abundance in any sample. That's it.